Good afternoon from London, friends, colleagues, and indeed customers around the world. My name is Hugo Kidston. I'm very pleased to welcome you to today's Data Center Construction Boom webinar. Now, data centers are by no means new, but what is very new is the scale, speed, and scope of the recent expansion and developments in this important segment. And today we're going to be hearing about risks and opportunities in that segment. Now let's take a look on the next slide at who we've got discussing this important topic today. So a very warm welcome to all four of them. We have Daniel Schroeder from our Allianz Risk Consulting team in Johannesburg, South Africa. We're joined also by Christian Kolber from the Global Practice Group for Construction Claims in Germany, and his colleague Stefan Zink, also in Germany, the global property industry lead for telecoms and data on the underwriting side. And finally, Jordi Basco Carrera, who's our head of private markets, global investment strategy at our investment management arm, Allianz Investment Management. Now let's take a look at what's on the agenda on the next slide. And we're going to be covering many different aspects of the data center segment. First of all, we'll be hearing from Jordi on the data center boom in terms of economics and financing. We'll be getting a risk consulting view from Daniel on what's the risk management, risk mitigation that can be taken. We'll be hearing a little bit on the claims side from Christian, and of course on the underwriting side from Stefan. Importantly, they'll have the opportunity to ask some questions at the end, so please have a think about that. And we'll be looking for some interactivity as we go through today's webinar. And with that, I'm going to hand straight over to hear a bit more about economics and financing from Jordi himself. Over to you, please. The stage is yours.
Yeah, thank you. So good morning, good afternoon. I'm going to just introduce a bit the topic of data centers, and to start with it, it's good to talk in the next slide about the infrastructure gap. Just as a quick reminder, we come from around 10 years, one could argue, of underinvestment in infrastructure in general. It was a moment where governments were actually quite fiscally constrained, and also policy rates started to increase a bit, making financing a bit, let's say, on the expensive side for them. So there has been a growing infrastructure investment gap across the world. And in that regard, private capital, and this is when we enter into the scope, the investment branch of Allianz, we're trying to help close this gap, introducing a bit of private capital to help economies around the world and build these necessary infrastructure investments. On top of this, we are moving into a world that is highly polarized. It's geopolitically loaded. And country sovereignty, also in terms of infrastructure, it's getting into the front of the agenda of all the governments. This means that even if there's not a lot of fiscal room, governments are trying to do the best that they can to close this infrastructure gap and to regain a bit of infrastructure sovereignty to be able to deal with these external challenges. If you look at the right-hand side of the chart, and here you see it, transportation has always and will always be, let's say, the main infrastructure gap or the main infrastructure focus of all the governments and countries around the world. But now we have two that have been growing quite a lot, that it's digital, which includes data centers due to the AI revolution, and also energy, which accompanies the data center revolution across the world. The early estimates are that we will need around $106 trillion until 2040 to close this infrastructure gap. And of course, this is not counting. This is counting a bit with exponential growth of parts of this infrastructure gap. But again, said 104 trillion, it's a lot of money that public and private capital are going to have to deploy. Moving to the next slide, and just referring a bit to the value chain, what we have seen since 1 year ago, and this is quite extraordinary, is that the consumption of tokens due to the AI revolution, it's actually in the quadruple digits, so plus 1,500%. And we have to remember that around only 5% of the population is actually using AI as a whole. So which means that the projection that we can have in 10 years time, it's massive. And the amount of compute power that we will need if we want to transform our economies into AI driven economies, it's going to be massive. So these numbers, although surprising as of today, may actually continue to increase vertically even and not exponentially. On the right-hand side, you see the adoption rates. The adoption rate is increasing massively and it's accelerating a lot, especially in white-collar jobs. Finance and insurance, like us, we are adopting AI really, really fast. Also, healthcare, it's adopting professional services, software, it's adopting, although we had a bit of a hiccup here, but other ones are going to be a bit more resilient or are going to have a harder time, let's put it this way, to adopt AI. This it's all that has to do with transportation, with mining, more blue collar jobs. But despite the message is that the adoption is fast and the need for data center and for AI compute power, it's increasing exponentially. And in the next slide, we actually find how this is reflected into data centers occupancy and demand. And on the left-hand side, you can see basically the prime rental rates, which have actually exploded almost 100%. It's 12% year on year, but on total, almost 100% in the last 5 years. This is a demand spike for data center, let's say, demand that we have not seen in the past for other sort of real estate or infrastructure investments. And interestingly enough, and you see it on the right-hand side, data centers that have not even been started or allowed to start right now are already pre-listed at around 80% capacity. This is extremely unprecedented, and it signifies basically that the demand is far outstripping supply to an extent that we have not seen before. And it also signals that this transformation or this AI transformation and the consequent need of data centers is a structural shift that everybody's banking on and not actually a blip or sort of a dot-com bubble exuberance. So it's a trend that we recognize that it's here to stay and that it will change the way that humanity basically operates and works in the future. Nevertheless, and in the next slide, we see the biggest hurdle that this AI and data center revolution has to go through, and it's basically energy. Energy consumption is increasing quite a lot, and not only energy, water as well. Water consumption is increasing quite a lot, and this is the biggest roadblock that we're going to have to data center construction and data center usage. And we actually have show this on the right-hand side. If we talk about the connectivity, so how much will it take for a data center to be connected to electricity and to have the connection it needs? And if you look at Europe, the average is around 7 times. This is what we are dealing with it currently. So it's 7 years delay until we can connect a big data center in one of these main European cities. In the case of the US, we know that it's a society that it's much faster when it comes to investment and deployment of capital. There it's more of around 4 years, and the investments are much bigger than in Europe, for example. But the message is that electricity will continue to be a bit of the big roadblock to this AI revolution and data center deployment. And this we are seeing it quite clearly, even there's a lot of efforts to try to mitigate this impact. So in the next slide, we actually have a summary of what I have been trying to explain with the last 3 slides. First, we have a massive increase in demand for tokens or for AI compute power. This means that we expect a massive increase in demand for data center capacity, especially for training and inference. And last but not least, the roadblocker, but also the one that is going to get the most demand peak is electricity. And this is something that we are, as an investment unit of Allianz, we continue to monitor extremely closely, because investing in AI and investing in data centers is extremely nuanced, and it's extremely more complicated than it may look in the front page of certain of the Financial Times or of The Economist. So in the next slide, we try to depict a bit this from an investment perspective, how we see this nuance or this complication in when it comes to AI investing and data center investing. And it's that for us, you're going to start from, if you want to get exposure to the AI revolution, to data center investing, you can go from the application side to the power side. And depending on the site that you pick or the bucket that you pick when it comes to this vertical, the risks and benefits are, or return expectations are actually certainly really different. And the market consensus of the market pricing, it's actually signifying this nuanced or differentiation between the AI revolution or the data center investing revolution. And this is something that we see on the right-hand side. You see it. If you are really exposed to service, so software and service exposure, your year-to-date performance when it comes to market performance is extremely low, actually quite to zero. And even if we would take the software as a service companies, it would be extremely negative, around -15 and -20%, because people understand that these are a sector or vertical that will suffer a lot from new technology and new software or LLMs that are going to come into play in the future. However, on the left-hand side of service exposure, you see year-to-date performance of around 30 to 35%, and this is AI infrastructure, which means that the market or market participants are banking on the picks and shovels, are banking on the bricks, and not that much on the software side of this AI revolution, which means that this is a supportive, let's say that it's a supportive fact for investing in data centers and investing in, people say, the return of physical assets. So investing in the physical asset that it's going to enable us to capitalize on this AI revolution. And on the last slide, this is our investing map. On the left-hand side, it's the ways that you can get exposure to data center investing. So on the left-hand side is the less risky part. So this is financing data center construction. It yields around 6 to 13% IRR or a yearly yield, depending on how big it is, where it is, the data centers. And it has a relatively low risk for the return that you're getting, being in terms of operational, counterparty market risk, because at the end of the day, you don't own the asset, and not owning the asset, it's basically quite of an advantage when it comes to the underlying risks of investing in data centers. However, if we move to the riskier side of the table, you have PowerShell or GPU infrastructure investing, and here you're starting to have expected returns of around 30% to 35%. This is extremely high. But of course, you have a lot of market risk, a lot of obsolescence risk, a lot of these data centers. When ASMD or when NVIDIA issues another sort of GPU, the obsolescence risk due to the extreme increase in computational capacity of these GPUs is extremely high, which means that the capex need for the data centers to keep themselves, let's say, competitive, it's extremely high. With this, we just want to say that we looked at data centers as a whole. We looked at the whole value chain and the way that we assess how we invest, or if this data center, let's say, rush or investment phase is actually interesting, is by looking at this numerous amount of segments, these different parts of the data center value chains that we can invest in, and we try to optimize, let's say, the risk of the owning the asset with the return expectations that we can get from investing in this sort of asset. So this is my main message. Electricity will be a roadblock, but demand is a structure, it's here to stay. And from an investment perspective, we really see data center investing and the real estate and the AI revolution as a trend that it's good for us to capitalize and to be part of it. And without further ado, I will leave the stage to Daniel to talk about the risks.
Okay, thank you very much, Jordi. So morning and afternoon to everyone on the call. So now that I have you temporarily captive inside your computer, I promise to use this moment responsibly and release my inner engineering nerd. So let's get started quickly. I'd like to just kick off with asking you a few questions and see what you would like to take from today as well. So you can get those phones out and scan the QR code you see on the slide. Otherwise, alternatively, you can go to slido.com and then put Allianz 1 in the browser. So I would love to hear, what are your strongest concerns when it comes to data center construction? And if there's anything I haven't got included, I will do my best to try and include it for you as well today. Just apologies to anyone on the call. I do have a slight cough at the moment, so if I do cough once or twice, I do apologize up front. Okay, so we've got a couple of good answers already. I see accumulation. Yes, NatCat, definitely something that is a prevalent topic right now. Fire and power supply, yes. Water resources, I completely agree with that as well. I see the word Texas. I guess that is maybe a reference to the exposures within that specific location. Grid connectivity, also another really good one. Okay. No, thanks, Alex. I do appreciate you also giving, like I said, these calls are also about understanding what you guys are fearing or what challenges you see as well as what we see. So thanks. So moving on to what we are seeing as a business is we're seeing construction frames, time frames change quite dramatically. So construction schedules have been compressed with less float and room for unforeseen influences. And this is typically due to an increased economic pressure and desire to compete with the competition. So, and also unrealistic construction schedules mixed with late changes in scope and technology adjustments can have a profound impact on a construction project, as well as on a contractor's ability to deliver the work. Scale, what's being built today isn't just a data center. It's a platform of the future. Budgets have leapt from hundreds of millions to multi-billion-dollar projects. Layout changes. This is one of the biggest significant elements, is data centers have gone from single standalone warehouses to hyperscale parks, often comprising of multi-story buildings. We're also starting to see interest in floating and underwater facilities being considered for the future. And natural catastrophes. Large data centers are being placed in remote areas, which naturally have heightened risks to natural disasters, such as convective storms, tornadoes, or even wildfires, and further away from emergency response teams, thus increasing the risks. Having a quick little look forward, scaling is obviously expected to continue into the future. I think this is an area of where we're currently all learning together. We're all trying to understand where the future of AI is going, what the demand will be, etc. There's an increased regulatory pressure that's starting to grow. So governments are starting to see the need to implement frameworks to address the impacts of data center construction and the scale of their construction into avenues like environmental and cyber as some examples. The oppositions to this from communities, we're seeing resistance worldwide as their footprints expand. These facilities are resource hungry, and this has sparked some tension over water consumption, infrastructure strain, and again, the sort of environmental impacts these facilities may have in the future. So moving across to the part I love the most, so civil construction. Let's have a quick discussion around this. So I think we can start this by agreeing that data center construction is nothing new in its primary form. They're essentially a warehouse building comprising of normal construction materials. However, where the change is coming is in the industry, how the scale is increased. The structural loads have vastly increased due to the density of some of the equipment coming in and the sort of layouts that have been implemented now. Shortened timeframes as well as the continuous scope and design changes also affect construction. So the big question I want to put forward to most people in this industry would be, does the design you have proposed inherently limit the loss magnitude? Because we can't always prevent a loss, but we can play a very active role in mitigating its effects the earlier we start to think about potential consequences of the decisions you're making. So, regarding construction, it's important to state that from our view, a complex project does not constitute a bad risk or a bad project for that matter. What we're wanting to consider is that the key aspects that make it complex have been considered, designed, managed, and addressed in an appropriate way that are, like I say, appropriate to the risk that they now introduce that maybe wasn't there 10 years ago. And if we were to try and formulate, what would a simple data center construction project look like? So let me touch on a few aspects. There would naturally be low NatCat exposures, simple single-story warehouse buildings, or a complex of spatially separated buildings. Again, we can all understand that if you have spatial separation between concentrations of values, that is naturally a big loss mitigating factor already. Having no prototypical aspects is also key. Simple topography profiles. We mentioned earlier that we're having to place these data facilities in less than ideal places now and outside of the city. So maybe you have to build on land that is not ideal and having to do things like basements, embankment cuts, etc. And greenfield construction is obviously always better. If we're building something purpose-made for a tenant, we understand the requirements at the outset. We're not trying to respond to late tenant requirements at minute 99 once most of the structure has already been cast. And then on the flip side, what would start to increase the risk? So natural catastrophes now being a higher exposure, multi-story data halls, which I will touch on again in a minute. If there's a power generation requirement and that power generation is close to the data center asset, prototypical aspects, like I mentioned just now. So if you have steep topography profiles with poor ground conditions, because if we have a high loading conditions with poor ground conditions, as we all know, that does tend to be quite tricky. Brownfield construction. So as mentioned earlier, if we're now trying to refurbish, retrofit, or change an existing structure that was never designed for the loads or the penetrations or the utilities that need to be routed through it, that does introduce a natural increase in risk. So a good example to show you of how data center construction has changed and how it's impacting maybe what used to be conventional risks is let's have a quick look at a multi-story data center. So multi-story data centers will present a higher loss potential than single-story because the risk is concentrated vertically rather than isolated horizontally. The fire and smoke can more easily spread between the floors through things like the shafts or the risers, turning a localized incident into a multi-floor outage or loss. And with data centers, the smoke is enough of a contaminating agent on its own to cause significant losses, even without a fire spread. Taller structures are also more exposed to extreme wind events, increasing the likelihood of facade breaches during the storm, or wind-driven sort of debris ingressing through the facade. Most critically, water leaks on the upper floors can cascade downward, impacting multiple white spaces throughout the building. So now that we've touched very briefly on some of the risks and the aspects behind it, let's talk about what are 3 of the main loss events that we could look into in the space of construction. So I'm going to move quickly across these, as some of my colleagues will touch on these as well during the topic. And I think, again, most of us know about things like fire, which is where I will start. So fires are generally rare in data centers, but the potential consequences of them can be severe, resulting in, like I say, threat to human life, loss of equipment, loss of the asset itself, as well as mainly the business interruption aspect, which we know can be quite significant. But what I want to mainly focus on around fire today is the lithium-ion side of things. So lithium-ion batteries are being increased in their use within the server racks in the data halls themselves. So unlike lead-acid batteries, these are actually being installed inside dedicated UPS battery rooms. Lithium-ion is now actually being integrated directly into the systems, whereas lead-acid would be separated from it. So in a sense of saying, this is a way of letting the fox directly into our henhouse. We're inviting the risk straight in. And what makes lithium-ion risks particularly concerning in data center environments is the potential for damaged cells to remain dormant for a period of time before igniting unexpectedly. One of the other key ones to address is natural catastrophes. So the scale of large data centers has seen them, as mentioned earlier, be built in remote locations. So now, while things like wildfires or tornadoes or floods, again, are not new, what is now changing is that we use flood as a good example. If you were building a building or a data center in a urbanized area, such as in a city center where you live, there are already infrastructure systems in place to mitigate the effects of storms, effective, stormwater systems that will help absorb a vast amount of the rainwater that falls. Whereas if you're now building a data center out in the middle of nowhere, then none of these are in place. We do not have the same warning systems that we would have in the city, as an example. So these are the types of things we need to consider when we're talking about natural catastrophes and the location that we select for the data center. Another important one to mention could be how you store your equipment as well. How would that be affected by flood in and out of the city? The last one I want to quickly touch on is water damage. So again, water damage is nothing new to any of us on the call, but it does pose a direct threat to things like the excavations, the basements, as I mentioned just now, stored and equipment installed or stored on the site. So either or of those are as vulnerable as the other one. Something that can be quite overlooked on a construction project is the storage plan. Are you storing your equipment that is sensitive to water above the floodline or below it? Are you concentrating it all on the site, or is it kept at an off-site storage until such a time as the project starts, or installing it as late as possible once your flood protection measures are in place? Water scarcity is a big one. While this one is a bit less intuitive, risks increase, driving design challenges, for more complex cooling systems, alternate water sources, or an accelerated commissioning, which all would naturally increase the potential for errors to be made. Again, this can be overcome by having something like a water treatment plant, maybe if you're using recycled water. But again, every time we introduce a new technology to combine with the data center, we are changing the risk. And then finally, something like water leaks, which are likely to come from cooling systems or fire systems. And again, as mentioned earlier, the way we can control the effects of this is a multi-story data center is naturally more exposed than if you had a horizontally separated facility. Then I would like to move on to one of my last topics for today, and that's testing and commissioning. So testing and commissioning is not a single event. It's a series of controlled risk steps. I cannot stress that enough. The testing and commissioning will represent, in 9.9 out of 10 cases, the highest risk phase in data center construction. And the reason this is because this is the point at which the individual systems that you've now installed in your facility, such as electric or cooling or fire protection, are energized and integrated and pushed to operational limits for the first time. And unlike other phases of construction, the failures now are immediate and high impact. So for testing and commissioning, a couple extra things I would like to just touch on is latent defects. So when the data center becomes live, your latent defects that were potentially invisible before, now is the first time you might learn about them. As opposed to something like the structural shell of the building, you have already started to load it by this point, so you would already have an understanding of the risk at an earlier date. Small errors, so something like an incorrect setting, sequencing, or torquing can cascade across multiple systems. Time pressure, again, one that really can't be emphasized enough. We've mentioned today about the effect of compressing the schedule. We cannot afford to compress a testing and commissioning schedule. One, to do with OEMs, to make sure that you meet the requirements of the OEMs who've supplied it, but also to ensure there's enough time for fault finding and corrective actions. Temporary systems, such as power and cooling, are frequently used before the permanent system is put in place and is fully resilient in its full-fledged design. And temporary installations thus often lack the redundancy and the protection that you have on your primary systems. Then lastly, the human interface risk as well. So the fact that you've got multiple contractors, multiple OEMs, all have different incentives in terms of meeting their completion dates, of trying to avoid their own personal penalties, all working in close proximity, again, carries a risk that has to be programmed and planned correctly. And then the last topic I'd like to quickly touch on is the power side of things. Now, power risks are by nature an operational risk in most of its lifespan. So I just want to touch on a couple of quick things to think about when power generation is included in the construction of the facility. So power is traditionally a mature, well understood system, and where it's undergoing a huge change now due to the AI-driven load growth, the sustained higher operating duties, grid connection and capacity constraints, and increasing resilience on integrated and non-traditional power sources. So what I would like to quickly touch on that we find as a high-risk exposure is we're seeing a convergence of several emerging construction risks. So firstly, the increased use of second-hand prototypical gas turbines introduces an uncertainty around their condition at time of receipt, the reliability, if you will be able to get OEM support for that asset, particularly during initial testing and commissioning. As mentioned earlier, that's one of our key areas of risk where it could accumulate. And this is a compounded effect where combustion engines are used as alternatives or supplements, often in high-density layouts with complex fuel or control systems that elevate fire and equipment damage risks. Demand uncertainty is another key driver as well, with late changes in the capacity or redundancy requirements from the power system. And finally, the growing integration of battery energy storage systems introduces a new risk profile during installation and commissioning, as mentioned earlier, specifically around the fire, but the causes can be thermal runaway, or as mentioned as well earlier, the defects that maybe have been lying in wait for us, waiting for us to get to the point where all of the money is invested, and that's when the battery decides to show us what was wrong. So thank you. I appreciate your time today. What I want to finish on is just to remind you that risk engineering is always more effective from the earliest point that we can get involved. The earlier you're able to make certain decisions, naturally the loss prevention handles itself. The claims experience does remind us why these design decisions matter, why thinking ahead and being proactive can help. Because as my colleague will now show you, technical failures do translate into real financial impacts for you as a client. Thank you for your time, and over to Christian.
Thank you, Daniel. Hello to everyone. I'm happy to provide a claims perspective on this topic, and I would like to start by setting the scene and presenting really quickly some remarkable examples of data centers. Then I would like to go on to provide a view of the risks that we see that we've identified from a claims perspective, go on to see some practical claims examples that we already see, and show you and give you an overview of our claims landscape in Allianz Commercial, and then conclude by doing a deep dive into fire as a risk and as a claim factor. So if we move to the next slide, this is really to provide an overview, and we can see here that most of the data center development is basically driven by North America and followed by Europe and Asia. You can see a slide that the Middle East is underrepresented. We could think that this is due to some constraints around power availability and the costs associated with that, as much as water consumption. If we now go to the next slide, this will give you some visual impression of really high-scale, large data center projects that are in the pipeline or already existent. And this is, first of all, a US view. So you can see on the left-hand side a real big data center campus in Port Washington, Wisconsin. And on the right-hand side, a data center hub of 70 different data center locations. And the US has been undergoing an unprecedented wave of data center expansion recently. And we've got over 550 new data center projects in the pipeline. Amazon, Google, Meta, Microsoft are the leading hyperscalers. So now if we move on, we will see an Asian view. And as Daniel has mentioned in several occasions, vertical structures do pose some different risks. But we can see here, and we've made a selection of some examples, but you can see two examples out of Singapore where we see vertical structures basically due to the space constraints that we have on the island in Singapore. So the first one on the left is ST Telemedia Global Data Centers, which is called Singapore 6. And it's a 70,000 square meter project. On the right-hand side, you will see Meta, also located in Singapore. And what is remarkable about this one here is that it's 100% basically powered by renewable energy. Now, and by contrast, you will see again a horizontal expanded example, which is located really next to Singapore in Malaysia. And here, obviously, we don't have space constraints and also, let's say, more favorable building and powering and conditions in terms of pricing. Yeah. So now moving over to Japan, and I think it was already mentioned, we have some floating data centers as a prototype that are being tested, and this is just to give you an example of one of those that is located in Yokohama. Now, if we move on to the next slide, you will basically see a selection of risks that we see over basically the whole value chain of those mega projects. So we can say that it starts by transportation risks that would basically impact our marine policies. And we see losses that stem from improper securing, theft during logistics, water ingress, transit damage. But we then go to a, let's say, complex phase of the project, which is the construction, and we can see that there's various risks here. We've got, of course, let's say the normal construction risks we would see in any sort of project, which is structural damage, earth movement, subsidence, building collapse, faulty design. But we also have, adding to that, problems around construction dust and the, let's say, the sensibility of the equipment that is being deployed here. Then testing and commissioning, as already mentioned, is a critical phase. And we see water damage as a risk that can happen both during construction and operation. As an example, we see fire as a risk that can also happen in both phases. We see humidity as a problem in general. And of course, storm, hail, and NatCat exposure. Now, if we move to the operational phase, we would see power, and this was already mentioned also several times, power outages or surges, disruptions in general as a problem. We can see over temperature claims, BAS fires, and also HVAC chiller malfunctions due to freezing, but obviously also cyber attacks. So now moving on the next slide, this is really to give you some aspects that are that we see on those claims. So high-rise data centers, they do face a significant physical risks with structural defects in cooling and power system, often leading to costly delays and disputes. We've got business interruption. So data center failures can lead to significant financial loss and also reputational damage, both for the operator and client, requiring robust BI and property insurance coverage. We've got cyber as a threat and risk as infrastructure is shared. Cyber attacks targeting building management systems or servers can cause widespread damage, triggering complex liability claims across multiple tenants. We also have environmental and nuisance claims. Increased scrutiny regarding energy and water consumption, along with noise or vibration complaints from surrounding areas, has led to increased environmental and liability risks. And also, we have disputes over performance issues like failure to meet technical specifications such as uptime standards or power capacity can result in significant legal disputes and contractual penalties. Now, on the next slide, and this is really to give you an overview of the different stakeholders that we see that can be involved or normally are involved in those mega projects. And without going into detail of these, this is really just to stress that once we move from, between phases, especially between the construction and the operational phase clarity is of utmost importance. It is important to make sure that practical completion is, documented, because we see lots of disputes arising out of conflicts, whether damage occurred during construction or during operational phase. In the next slides, I would like to give you an overview of the claims landscape that we see in Allianz Commercial so far related to data centers. And if we start by moving to the next slide, we will see a geographical spread of claims, and we can see that there is a high frequency of claims in Europe, followed by North America and Asia. Now, if we look into the severity of claims, those is still led by Europe, but closely followed by America, which would give us an indication that claims in the US might be costlier. Now, on the next slide, we will see an overview of lines of business affected, and again, we look at it from a frequency and severity perspective. So, in terms of claims numbers or amounts of claims, property or the operational phase would be leading the picture, followed by financial lines, which is mostly professional indemnity claims, and then construction. On the severity side, however, construction would be second after property. And we can see in the pie charts that in the operational phase, the real driver of losses is or severity is business interruption. Now, if we move on, we've also looked a bit into the main causes of loss. And we can see here that by frequency, this is led by water damage, closely followed by willful acts, which would be cyber, and fire coming third. Now, if we go to the next slide, we see that the severity, however, is driven by fire claims, and natural hazards coming second, then third, cyber, and fifth, water damage. Now, please to the next slide. Here, I would like to give you some practical claims examples that we currently see. So this is not an extensive list. We've got much more, obviously, but this is just some examples. So, and I would like to talk to each one of them real quickly. So the first you can see here is an AI data center. And here the loss involved cracking damage to chiller units. And during construction of the chiller building, and the reason, or let's say the cause of the loss, is due to both operation of those chiller units outside of the specification, but very cold ambient temperature that led then to a freezing damage. And you can see on the right that is a multi-million-dollar loss. The second example is fire, and I will talk more about fire going forward, but this really happened also during construction, during hot works. There were some sparks that basically led to a fire of the filter mediums, and the problem here was that soot migrated through the wide areas of the data center. And as you can see, quite very significant multi-million dollar loss, between 50 and 100 million. The third example is also during the construction of a data center, where a data center suffered damage to HVAC dry cooling units that were already installed on site on the yard, and they suffered damage due to hail and strong wind. Now, what is remarkable about this one here is that is the concentrated value that we have on those chillers, and each of them has a value of around $360,000 to $400,000. And we've got 60 affected here. On the fourth example here is a power disturbances that led to a problem during data center construction, and this is out of this list the only one that has a delay component to it. So there was significant delay to the whole project due to these power disturbances. And the last example is really to give you to kind of round off this, but also to give an overview into everything that can happen. So this is something that is not really related to a data center, but it happened during the construction of a data center, and it's a bridge collapse on construction site of this data center. Now, moving on, and as I said, I would like to talk a bit more about fire as a risk and fire claims. And I'm taking an example here that is a fire loss that occurred in South Korea last year. And in this case, South Korea's national data center crippled some governmental online services and internal networks. It was suspected that the fire started with an explosion of the battery during maintenance, damaging some servers and forcing shutdown of hundreds of others. Now, the fire led to a thermal runaway, and which produced extreme heat in the server room, preventing firefighters from taking aggressive actions to contain the blaze. 600 servers remained in forced shutdown to protect data, while firefighters worked to extract nearly 400 battery packs from the building as a safety measure. Now, taking this example to talk about restoration, reinstating data centers is a complex and high-stakes process that involves specialized labor, hazardous waste disposal, and structural demolition as well. Replacement of specialized equipment, infrastructure rebuild, reinforced floors, specialized HVAC systems and cooling networks is complex. And when it comes to reinstating servers, for example, and electrical equipment, the first question we need to start asking ourselves is restoration technically and economically feasible, and which also leads us to the question of manufacturer warranties. So repair activities in general include sprinkler systems, data retrieval costs, and expediting expenses. And as part of the reinstatement, we also have to consider temporary solutions, interim hardware, and temporary locations to minimize operational disruption while permanent repairs are ongoing. Now, costs can vary significantly based on the facility size, location, and power capacity, and it is a massive undertaking that often requires specialized IT asset disposition vendors. Now, other general aspects related to fire that we have seen is that the noise, and this in a more, let's say, on a more general note, noise created by alarms of fire suppression systems and vibrations that result of that can damage the servers, wrecking it at times maybe too high and therefore too close to the sprinkler systems. Gas suppression systems are very sensitive and that can lead to them activating an error due to, for example, haze or construction dust, which then can lead to a mistaken, or let's say to a dump of gas that is not intended, and that obviously can have quite a financial impact or damage. And then, as already mentioned before, contamination and humidity is a problem due to the risk of reducing, in general, the equipment lifespan, and due to corrosion risk that can lead to hardware failure. Now, on the next slide, I would like to mention and really touch upon some other risks that are worthwhile mentioning. And this is also more on from a general perspective. So supply chain disruptions can obviously affect any sort of construction project, but also data center construction projects. And these are unexpected events that can interrupt the usual flow of goods and services or information within the supply chain. And they can occur anywhere, to manufacturers, suppliers, distributors, and even customers. We know that from industry analysis that manufacturers are booked solid with many components and large scale power generators designed for AI facilities, creating shortages for utility companies and other sectors. These disruptions can really also lead to delay and reinstatement of ongoing claims, which leads us to business interruption. So business interruption typically follow physical damage and include loss of revenue, lease payments during downtime, and penalties in general. So we do significant penalties, costs arising from downtime penalties, which may not be covered by traditional property insurance. Power supply, as mentioned already, and grid stability is a risk, and in general, and currently grids are not fit for future increased demand of data centers. And finally, and to conclude on this slide, lack of maintenance can also, let's take the gas suppression system, they can activate due to lack of maintenance as well. Now, on the next slide, and this is really to conclude my part, this is really to show you and give you a flavor of other things that can happen, and it's a current development, geopolitical developments we are seeing globally now. It can lead to attacks of critical infrastructure. This is also something that can happen, and the impact of this, if we just imagine a data center being attacked on society, would be really, really big. So with this, thank you very much for your attention. I would like to hand over to Stefan.
Thank you, Christian. And so welcome from my side. And I'd like to wrap up today with some insights into underwriting considerations. And if you can go to the next slide, please. Let's start with looking at sort of the different categories of data centers left to right from an underwriting perspective. The first one are traditional enterprise data centers. So they're company-owned on-premise facilities. They serve predictable workloads. They're declining as cloud adoption accelerates, and so underwriters have experience here. Those are manageable risks. They're well understood exposure, and that's sort of the traditional types of data centers. And similar to that are edge data centers. What are they? They're smaller distributed data centers. They're designed to be closer to end users, mostly for low latency applications like Internet of Things. They're growing fast. They have a slightly different risk profile, but overall broadly similar to traditional data centers. You have an example picture here in the bottom left on the screen. And those are also fairly well understood by the underwriters. Now the complexity starts to increase when we look at co-location facilities. Those are multi-tenant environments where we have shared power and cooling infrastructure. They're growing in scale and power density, and you even have increasingly hosting hyperscalers as anchor tenants in those. So for an underwriter, that means higher aggregation, greater dependencies, more demanding accumulation pictures, and finally, hyperscalers, and as sort of mentioned by previous speakers already, they represent an entirely different category. So they're purpose-built campuses, very large, direct grid connection, substations on site, and they're no longer just IT assets. They're critical national infrastructure. And the risk focus extends from the buildings themselves to the power grids, water supply, and ESG dimensions. So change is happening fast, and underwriting needs to keep pace. And with that, the next slide, please. We have the data centers, and they're not simply large warehouses filled with servers. They are already, natural infrastructures that are part of the digital economy. And the successful operation depends on the seamless interaction of power grids, water supply, and data connections. So as we already heard, power is the most critical dependency. Those data centers require high capacity electricity, which means grid stability, redundancy, and on-site backup generation is essential. But with that dependency on power infrastructure, you also introduce things like exposure to upstream failures and new on-site risks, like we heard, lithium-ion battery fires. And a similar logic applies to water, where availability and the environmental restriction can directly affect the operation continuity, but also lead to water damage from liquid cooling systems. And sort of the connectivity of data centers further sets it apart. The proximity to fiber routes, major network nodes, so is a genuine competitive advantage, and especially for cloud services and real-time applications. But that dependency also on external data links creates vulnerability to physical cable damage, regional power outages that may originate far from the insured site. So recognizing data centers as critical infrastructure hubs allows insurers and clients to take a holistic risk view. So what does that mean? Rather than focusing solely on the building envelope, we look at the interdependencies, the single points of failure, and systematic exposures. And it also supports better design decisions, so targeted risk mitigation and insurance structures that reflect the true role of data centers in today's modern economy. Meaning this is not an Allianz challenge or an individual client challenge. It's a market challenge. But we as Allianz can be there along the way. And next slide, please. I'd like to spend a little bit of time talking about an insurance view of a hyperscaler data center. Now, accumulation risk arises when multiple insured interests converge in a single physical operational ecosystem. And then the risk is not driven by one policy alone, it's built up across layers. Operator, multiple tenants, ongoing construction, and supporting utilities all concentrated in one place. And the foundation is the operator layer. So you have property damage coverage for the physical structure, obviously, and loss of rent coverage for the revenue. Typical loss scenarios: fire, flood, power failure. So we have seen earlier, they can become big losses quickly because there's so much going on at these facilities, which brings us to the tenants. So you have the clients that deploy servers, networking hardware, storage systems, and increasing the value per square meter at these sites. So a single event can trigger multiple equipment and business interruption claims all at the same time. And when the tenant, for example, stores equipment on site during upgrades or migrations, you have exposure spikes and even things like stock throughput policies involved. Then you have construction, as we are hearing, sometimes these sites getting expanded, and those live expansion projects adjacent to operational data halls, hot works, contractor interfaces, transitional power interfaces, all overlapping that can impact both the operational and the construction policies all at once. And finally, supporting infrastructure, as we heard, some of these campus-style data centers have on-site power plants or water pumping stations. They bring their own risk profiles. You have machinery breakdown, fuel supply failure, which may seem contained in a space, but it can quickly cascade into a campus-wide business interruption. And I would say the key message is It's complex, and there's a lot to consider when underwriting these hyperscalers. But again, what does it mean for insurability? And next slide, please. And the core is really the interdependency. So you have the data centers, and they combine elements of real estate, industrial infrastructure, and highly sensitive technology environment all in one place. So an effective and coordinated insurance buying is essential to avoid gaps or overlaps in case of a claim, which you also heard during the claims section. Also, to pay attention to the emerging risk profiles. Those hyperscaler and large colocation facilities they're evolving so quickly. So you have server architecture changing, power densities increasing, direct-to-chip liquid cooling, new business models. We're no longer talking for the developers just providing lease space. They have full performance SLAs, which require an entirely new approach to risk assessment. Now, what does that mean? What does good risk quality actually look like? Location matters, obviously, for natural catastrophes, avoid floodplains, but that's not all. Building quality, business continuity planning, access to water, and critical supporting infrastructure are equally important. And most importantly, systems should be designed for replaceability and resilience. So clear physical separation between fuel sources, reducing the fire risk, taking care of the batteries. These are the foundations of long-term insurability. And now that makes one thing essential, and that is transparency. When material changes occur during construction operation, insurers need to know. The transparent communication ensures that the insurance program evolves with the asset, providing continuous coverage, stable capacity, and terms over time. And the shared objective is clear. Clients, brokers, insurers, investors, and tenants, they all benefit when the insurance program accurately reflects the risk profile of the facility. And of course, building that proactive partnership over time reduces uncertainty, creates the long-term partnerships that are needed for these type of digital infrastructure going forward. And Allianz can be there to support that journey. And with that, thank you very much, and back to Hugo.